subtracting polynomials algebraically. And just like when we had adding polynomials algebraically, we have two methods we can do this. We can use our horizontal way of subtracting, or we can use our vertical. So again, I'm going to show you both and show that you derive the same exact solution if you do all of your math correctly. So first, if we're going to use horizontal here, the one thing I suggest is you notice that this is subtraction, which means that you're subtracting everything on this backside polynomial, which means that all of these signs will change when you're trying to add them, when you're just trying to combine them. So I suggest that we change the signs on the backside. So by doing that, I rewrite my first polynomial. And then what we're going to do is we're going to distribute this negative into each term of that backside polynomial. I'm going to change this to a plus. What I'm doing is I'm distributing this negative into it. So therefore now I'm just adding and combining like terms. So negative times 2x squared gives me a negative 2x squared. Then I have negative times negative 3x. Again, I'm just changing the sign, so this gives me positive 3x. And then lastly, a negative times 4 gives me a negative 4. And then this becomes just like we did previously in adding polynomials algebraically. We just combine like terms. So we look and we say, all right, well, here's my positive 3x cubed. There's no x cubed over here, so I don't need to combine it with anything. So I just get a 3x cubed. And then look at my x squares. This is a negative 4x squared. Here's a negative 2x squared. When I combine those, I get a negative 6x squared. Next, I just keep moving through and I look at my order my variables, sorry, my exponents for my variable, and that's just 5x, so it's just x. So I have 5x, and then I have this positive 3x. You add those together, and you get positive 8x. Lastly, we go through and we have our constants. So negative 1 plus a negative 4, which gives us a negative 5. And this would be our solution for this problem here. Now, again, that's horizontally. Vertically, it's a little different. So if we go vertically, we rewrite 3x cubed minus 4x squared plus 5x minus 1. Now, essentially, probably the easier way so you don't see all these sign changes everywhere is to go through like we did up here and distribute the negative into everything. And then that way you just add all of the signs already changed. However, I'll show you another way. That way you can see the sign changes in the same type of problem. So we have, we're gonna line up like terms. So we have a 2x squared, and then we have minus 3x, and then plus 4. This was our original. Now remember, this is subtract, which means that if you look back at here, when we distribute this negative into everything, we just change all of the signs. So we're gonna do the exact same thing. So how I like to look at it is I like to say, okay, well, I'm gonna change every sign down here in this second row. I'm change this to a negative and a positive and a negative. Now I can add straight down vertically with like terms like we've done in previous with adding, because now it does say addition. So 3x cubed, there's nothing to match it with. We get 3x cubed. Negative 4x squared minus 2x is negative 6x squared. 5x plus 3x gives us a positive 8x. And then negative 1, and now we're adding it to a negative 4, gives us a negative 5. So here's our solution, and you can see again that regardless of which way we use, horizontal or vertical, and when we subtract, we should get the same answer.